Whether we like it or not, software development is changing. Don't get me wrong, I love writing code, I am writing code on a daily basis, and I believe I will still be writing code 10 years from now. However, the reality of code generated with little to no technical knowledge is now a reality. In recent months, the rise of low-quality, unverified or hallucinatory code generated by LLMs has led several major open-source projects to halt or heavily restrict external contributions. Just a few days ago, the founder of TiltRaw, a very popular Canvas library, officially paused all external pull requests because the PR authors didn't understand the code they were submitting, they failed to follow up on review comments, and they provided misleading context. The curl project also ended its bug bounty program because people were spamming the project with AI-generated reports. So we are seeing the rules for open-source contribution changing before our eyes. Developers are putting safeguards in place to keep their codebases clean from AI slop, but I doubt this will solve the actual problem. I believe that in the next couple of years, the quality of code across the world will decrease drastically. It is now too cheap and too easy to output code. So this code will be written, shipped, merged, and deployed without understanding context or ownership. And remember that these code generation models are context-dependent, so with the code quality going down, that context degrades as well. Models learn from what we produce, so if the average quality of code in the world drops, the training signal degrades with it. The biggest limitation of these AI models is that they operate almost entirely at the mechanical level. In 1986, Turing Award winner Fred Brooks published a paper pointing out something we all know by now. The hard part of software is not the mechanics, it is deciding what to build and understanding how it should behave. So, optimizing the mechanics aspect of coding will not have a huge impact on actual software productivity. These AI labs keep optimizing the mechanics because they are visible and tractable. You can measure them in lines of code written. But quantity is never a good metric. If all of a sudden everybody can easily generate thousands of variants of the same half-baked, barely working SaaS product, we haven't increased innovation, we've increased noise. You can already see this in the wild. There are around 4.3 million apps published across the App Store and the Play Store, and the data shows that the top 1% of app publishers generate 80% of all new installs. The remaining 99% fight over scraps. Most apps are never meaningfully used, never updated, and never maintained. If 1 year from now we end up having 10 times more apps published in the stores, the chances are we'll still be using exactly the same small set of apps we already rely on today. One thing that will not change for certain is the need for good software developers with a good understanding of fundamentals who will have to tackle the consequences of all these 10x Markdown engineers. In this new era of noisy AI slop, first principles matter the most, because when output becomes cheap, principles become the constraint. This is not unique to software. Ray Dalio's principles exist for this exact reason. In complex systems with delayed feedback, survival depends on explicit rules for decision-making. So I'm starting a new weekly video series called First Principles, where we'll discuss news, mistakes, and skills that really matter in modern software development. I think this will be especially useful these days when the industry is optimizing for output instead of understanding. Today, we'll look at a really interesting story about the impact of modern web hosting. In short, the convenience of abstracting away all the complexity of a software product could lead to funny situations like ending up being financially ruined by someone else's crawler. In one recent Reddit blog post, a developer described how Meta's crawler hit their site 11 million times in 30 days, and how every single one of those requests was happily converted into paid compute by their hosting provider. And the hosting provider is, you've guessed it, Vercel. The breakdown of monthly requests is actually really interesting. During a 30-day period, the app received 24 million real user requests and a combined 19 million requests from crawlers, with Meta alone accounting for more than 11 million of them. In other words, a bill that was $30 in November grew to almost $2,000 in January. For context, Googlebot, the crawler that actually sends traffic to websites, made barely over 1 million requests in the same period. Meta was hitting the site roughly 10 times harder than Google, most likely for AI training or some other suspicious activity. The scale at which these companies operate has completely detached from any notion of reciprocity. Crawling used to be a tax you paid to be discovered, but now it became extraction at an industrial scale performed by companies that neither need your permission nor suffer any downside when they overwhelm your infrastructure. But the real problem here is, again, the removal of responsibility through abstraction. The core promise of serverless is that infrastructure decisions like choosing machines or configuration details are no longer your problem. You deploy code and the platform guarantees availability and scale. Sure, traditional hosting on platforms like AWS has its own set of trade-offs and complexities, but the responsibility model is fundamentally different. On traditional infrastructure, whether that's raw EC2, managed Kubernetes, or even old-school VPS hosting, you have to go through the steps of explicitly thinking of your app needs, estimated traffic, and other constraints. Sure, that's more time-consuming and requires more time and knowledge than a seamless serverless setup, but going through this process makes you responsible for the consequences of your decisions. And this is one of the core principles good software developers need to follow moving forward. You need to be able to own, explain, and stand by your work. A few days ago, I read a really interesting article stating that SREs are the future of software engineering. For those unfamiliar with the role, Site Reliability Engineering is a role formalized by Google in the early 2000s. The role describes engineers in charge of operations, reliability, and infrastructure. I don't fully agree with the article, and I'll explain in a second why, but some ideas are worth considering. When code gets cheap, operational excellence wins. As we've seen in the last couple of months, anyone can spin up a barely working greenfield demo, but very few can create the context for that demo to become a real product. But while the mechanics of writing code can be automated, time and time again, it has been proven that people are always needed to keep the systems running. However, I don't believe that this is the only path moving forward for us. There is a big difference between software development and just generating code. And I would argue that none of these two problems is currently solved by AI. However, getting back to the idea of owning your work, this article sums up the importance of ownership pretty well. Modern software appears stable because abstraction hides fragility. In reality, most production systems are thin layers of in-house code built over large dependency graphs. The majority of executed code is external and implicitly trusted. And from a technical perspective, dependency management is an ownership problem. Using other people's code or a hosting platform implies obligations like evaluating the dependency health, reducing unnecessary transitive complexity, and actually understanding what that tool is doing for you under the hood. And before wrapping things up, here is your awesome trivia for the day. Owning your work and making sure that software runs reliably is a challenge as old as computing itself. You might think these black box failures are a byproduct of modern AI, but the ultimate lesson in first principles engineering actually comes from 1969. During the Apollo 11 moon landing, as Neil Armstrong and Buzz Aldrin were descending, the lunar module's computer suddenly started screaming a 1202 alarm. It was a critical system failure. The computer was crashing and rebooting in a loop. Neither the astronauts nor most of the team at Mission Control knew exactly what it meant in the heat of the moment. It looked like the mission was over. But a 24-year-old engineer in Mission Control named Jack Garman had spent weeks obsessively studying and understanding the priority scheduler. He realized that the alarm was the computer doing exactly what it was designed to do. A faulty radar was spamming the system with garbage data, essentially a 1969 version of that Meta crawler hitting a Vercel site, and the computer was being overwhelmed by noise. So the computer was hallucinating a crisis because of bad input, and the day was saved by somebody who understood the mechanics underneath the abstraction. If you liked this video, you should consider joining our community where I'm posting more dedicated content. Please don't forget to smash all the buttons, and until next time, thank you for watching.